So let's first talk about slope. In order for a function to be linear, it needs to have a constant rate of change, and we call that a slope. And we can also call that gradient. Both of them mean the same thing. So just to review, the equation for slope is y2 minus y1 over x2 minus x1. And to get that x1, x2, etc., you're looking at 2 points. So if you have the point 3,2 and the point 5,9, we're just going to label one of these points point 1 and the other point 2 and plug those into the formula. And then just a couple key things to remember. To get a zero slope, 0 happens whenever you have 0 divided by any number, and it's a horizontal line. An undefined slope happens when we try to divide by 0, because dividing by 0 doesn't work. You get error on your calculator. So that's undefined, and that would be a vertical line. All right. So if we want to find the gradient of the line that passes through these 2 points, just like I said, we're going to label these point 1, point 2. So I'm going to label this first one my x1 and y1, and the second one my x2 and y2. And then we're just going to put this in the formula. So m equals y2 minus y1 over x2 minus x1. So we get 10 minus 8 over 7 plus 3, which is 2 over 10, and we can reduce that to 1/5. So my gradient is just 1 over 5. So let's find the gradient using a graph. So on a graph, we can just simply count the slope by finding the rise over the run. What I see as a common mistake that students do is they don't find two what I like to call perfect points. So if I tried to choose like this point, for example, right here, this would be very hard to read because yes, I can see that it aligns with 3 right here on the x-axis, but on the y-axis, it's slightly below what would be like 4.5, so that's not an easy point to read. So instead, I always like to choose points that are right in the corner of the boxes. So this one right here is perfectly at 2 and 3. And then this one right here is perfectly at -1, -1. So those are easier to use. Once I find my 2 perfect points, we are just connecting them and finding the rise over the run. So the rise here to get from this bottom point to that top point would be going up 1, 2, 3, 4 spaces. 1, 2, 3, 4. And then from there, I would go to the right 1, 2, 3 spaces. So up is positive, right is also positive, so my slope is positive 4 over 3. If you ever go left or down, those are negative directions, so you would use that as you see fit. So now that we've reviewed slope, let's go ahead and talk about equations of lines. So you're probably the most familiar with slope-intercept form, and that one is where we have y equals mx plus b, where m represents the slope, and b, it represents the y-intercept, which is the point where our line crosses the y-axis. So that one is pretty easy to use. We also have point slope form, which a lot of people don't use, but it's actually sometimes the easiest one to use. So we'll talk about that. But the way that it works is you just need your slope and then any point, and your point goes in here. So your x value would go there, and your y value from the point would go there. And then my least favorite is standard form. This one isn't super helpful, but IB really likes to throw these on the exam and make you turn one of these into standard form. So we'll talk about how to do that as well. The important thing with this is your A, B, and C values have to be integers. So sometimes we have to multiply to get all of our numbers to end up being integers. But we'll talk about that shortly. All right. So let's start with this example. So we want to write the equation of the line through these 2 points in slope-intercept form. So first thing I need to find is my slope. It says it right in the name. So we already found slope previously. We're going to do, this is going to be my oops, this will be my second point. This will be my first point. So we're going to do 3 minus 8 over 7 minus 0. And that comes out to negative 5 over 7. So that's my slope. And then we also need the intercept, which we do actually have. The intercept happens on the y-axis, which is when x is 0. So that's telling me right here that 8 is going to be my y-intercept. So to write this out, we have y equals m, which is right here, x plus b, which we just said is 8. So this one's really easy to do only when I have a slope and an intercept. A lot of times you don't have an intercept, and that's when I would use point slope form, which we'll do next. So for this one, again, we have 2 points, but we don't have a point where the x value is 0, so I don't know what my intercept is yet. So what we can do is I'm first going to find my slope, because this one's also point slope form, so I'm going to need slope. So I'm going to do 10 minus 7 over 9 minus 4, which is 3 over 5. Okay. Now that I have that, the only other thing I actually need is a point, and I have 2 to choose from. So you can choose whichever one you want. I'm just going to choose this first one and go from there. So we have the equation y minus y1, x minus x1, and we're going to plug these in. So we have y minus my y value of the point, which is 7, equals m, which is 3/5, x minus my x value, which is 4. And then let's say we actually wanted to take this and write it in slope-intercept form. All I would have to do is a little bit of algebra. So I could distribute my 3/5, and I'd get y minus 7 is 3/5 x minus 12/5. And then to get y by itself, we're going to add 7. So we get y equals 3 over 5x. And then, so I'm going to rewrite this as 35 over 5 to get a common denominator, plus 23 over 5. So point slope form, we could have stopped here, but if they wanted slope intercept, we can take that and turn it into slope intercept form. All right, so let's now talk about how to turn these into standard form. So my first equation was y equals, I'm going to write this down, negative 5 over 7 x plus 8. Okay, and then we just have the other one over there. So standard form, if you noticed before, or if you saw it before, that's where we have ax plus by equals c. So the first thing I want to do is get my x's and y's on one side of the equation. So I already have my y on the left. I'm just going to add over my x to both sides. So I have now 5 over 7x plus y equals 8. So all of my variables are in the correct place. The last thing I need to do is get all of them to be integers. So to do that, we're just going to multiply the whole equation, both sides, which keeps it equivalent, by whatever denominators we have. So in this case, I have a denominator of 7, so I'm going to multiply everything by 7. And what that does is when I distribute here, that cancels it out, so now it's just 5x. Distributing here gets me 7y, and then distributing to my right side of the equation is 56. So now I have ax plus by plus c, and all of them are integers. That's it. So let's practice one more. Let's do our other equation from part 2. So we have y equals, I already turned it into slope intercept, so we'll go from here. Again, we can get our x's all on one side. So I'm going to subtract my 3/5 x. So I have negative 3 over 5x plus y equals 23 over 5. And then to get rid of the fractions, I'm going to multiply by 5. So I get negative 3x plus 5y equals 23. So in this video, we learned how to find the slope using the equation y2 minus y1 over x2 minus x1. And we also talked about the 3 different forms of the equation of a line. And just a reminder, we have slope-intercept form, we have point-slope form, and we have standard form. Oops. Thanks for watching.